Okay, so this is part 4. We're continuing on with our chained hash table. We're going to do a remove method. This time I coded the remove part before you had a chance to even see. I coded it when you weren't. So if you need, pause the video and get your code in for your remove method here. Okay, a remove method is super similar to the contain, so I'm going to kind of reference back to that quite a bit. One difference though is we need to see if our table is empty. If our hash table is empty, then there's no point in removing from the table because it's empty. So I'm going to give them a runtime error that says table is empty. Okay, if it's not empty, I need to get my key just like I did in my contains method, and I will also need the current. So I'm going to grab that from my contains up above. Okay, I'm going to need one more additional pointer. So I'm going to say node type. I'm not setting it equal to a value. That's why I can't use the auto keyword. That's a terrible name. This is going to be the previous pointer. I need to reference in order to chain things around. I need where I'm previously at. So node previous equals, we're going to start that at null pointer. Okay, so while my current exists, I'm going to see, once again, just like I did above, if cur info equals the item I'm going to delete. If it is, then I need to see if my previous value exists. If my previous value exists, then that means, which I haven't defined yet, so at this point it's null pointer, but later on, if that particular first item in the hash has multiple chaining, previous will exist as a value. So I'm going to set my previous link equal to my cur link. So that will get rid of the current value. Then I need to delete my current value. All right. So if that previous does not exist, then I'll just set my hash table of t equal to null pointer, and then I'll delete cur. So that way it's deleted. I also need to update my size with a size minus minus, and I need to return true. If I could spell return. Darn, I hit cap locks. And what that does is that says, okay, we successfully deleted that item. Okay, now here's where I'm setting my previous value. Is after this if statement, so this bracket ends this else, and this entire if else return true is all contained inside of this item. After that, I'm still inside the loop. So I'm going to set prev equal to my current value, and then I'm going to move my current value equal to the next position. And that way when it comes around, so the second time, if it's not the first item, it's going to remove that, it's going to keep going, and that way it'll define my previous value as the previous item in the list. Okay, so long as it hits through this list, then it will delete it. If it makes it through this entire loop and does not find the item, that means that the item is not in the list, and we will return false, saying the item did not get deleted because it wasn't in the list. Okay, so that is it, theoretically, for my remove. Oh, it has no member next. What did we call it? We called it link, didn't we? Link. There we go. Sorry about that. We did call it link. And that should, and T is not, oh, I called T, what did I call T? I called T key. So I'm going to switch this really quick to key, and that should, sorry, some of these default names I forget when I'm trying to make it more understandable. All right, so that is it. We'll fix this one out later. We haven't coded this yet, and that's why it's giving me an error. But my remove should now work, and it should function. And we will catch you in the next video to fix that last error, the extraction operator, and then our program should be done.